Well, good afternoon, everyone, and welcome to our final Google Hangout of our Exploring the Oceans massive open online course. I'm John Copley, one of the educators on the course. Hopefully you might recognise me by now from some of the videos. And this afternoon we have some of the other facilitators and educators with us. So would you like to just introduce yourselves?
I'll start. I'm Christian. I've been one of your mentors, and I'm a physical oceanographer. I've been lucky to have been in a couple of cruises and going to one soon, and I'll be talking a little bit about life on a cruise.
Hi everybody, I'm Josh. I'm also a PhD student here at the National Oceanography Centre. My areas of research are particularly canyon sedimentation and also submarine landslides. Similar to Christian, I've also been on a number of cruises, and hopefully we'll be able to share some of our experiences with you this afternoon.
Hi, I'm Flick Williams. I'm a paleoclimate researcher here at the National Oceanography Centre. I'm particularly studying past sea level and how that changed with relation to the growth of the ice sheets. I'm here in the course to talk about things that I've done whilst on a cruise, and that's it from me. Thank you.
Hello, I'm Verity. I work with John on deep sea biology at the University of Southampton, and hopefully you'll know me as one of your educators.
Okay, well, thank you all for your questions that you've posted in the forum for this step and sent in via various other means as well. We'll chat now, I think, for half an hour, 40 minutes or so, getting through as many as we can, and I'm sure we'll also be able to revisit some of those that we don't in the discussion forums online as well. Of course, last week we were looking at how we explore the oceans and the sort of logistics and planning that's involved. This week we're looking about our impacts on the oceans and the future of the oceans. So we'll cover broadly those two areas with questions that we've got. So looking back to last week and life at sea, we've had quite a few questions about that. We've had a question from Brian Donnelly, who says he works in the offshore industry. And do scientists going off to sea need mandatory sea survival training and various sort of qualifications? So I'll throw that one open. There's quite a simple answer to that one, which is yes, broadly. We do. So have you all done your sea survival training, those of you who've been to sea?
Yes.
Yes.
Times.
Just in reference to the question, the specific requirement for all scientific parties aboard the boat is the STC W95, I believe. Which is minimum requirements for all scientists on board research cruises. And
that's for British research ships, and other nations have different requirements as well. And interestingly, so when we have international colleagues joining from the United States, they need to get that specific requirement, or there is a list of equivalent international requirement that can sort of be translated and so on. But sometimes it actually means they need to, at some point, get over to Europe, the UK, or whatever, and take the specific course that they need. But it is a serious issue, making sure that we're prepared for any sort of eventuality, emergency situation like that. And whilst the training is very serious in that regard, it's also quite an experience in bringing people together as well, as you figure out how to climb in and out of life rafts and turn them the right way up and all these sorts of things. So yes, we do go through all that kind of training. Another question relating to life at sea. Several people have commented how they, got asked about seasickness, and scientists can get seasick, of course, and we're not kind of self-selecting. The only ones who go to sea are the ones who don't get seasick, and actually everybody, I think, gets seasick. It can vary with the boat, the conditions, your physical condition, all that kind of thing. So the question is, what do we do when we are seasick? It's a very good question. So what have some of our experiences been?
Yeah, sure. What I personally do is prevention to start with. Every time I start a cruise, I start taking seasickness tablets, whether the sea is rough or not. And after a couple of days, you kind of get a bit used to it. But then sometimes you can't do much when it's very rough and you just get seasick. And I just try to keep some dry food in my stomach, or like bread, sometimes apples, and keeping myself busy and looking at the horizon is also usually a good way to keep going and having some fresh air blowing on your face. I don't know, what about you?
I mean, it's only in particularly bad weather that I find myself being completely incapacitated. But in a lot of instances, when you're doing deck work aboard ships, particularly deep sea coring, that type of work actually can't usually be done in rough weather. So I suppose the impetus to work is lessened by that fact. So it allows you time to sit down and relax and try and feel a little bit better. In other cases, people working indoors on computers and seismic equipment aren't so lucky. They often have to work irrespective of the weather. I feel sorry for those people sometimes.
I'm very lucky in that I've only just felt vaguely queasy once, which I was on a very stable ship, so perhaps that helped. And the queasiness was caused by being in a room in the middle of the ship with no view of the outside world. So to recover from that, just a little bit of fresh air and some water, and I was okay. But I think that the main thing that I feel when I'm on board ship, not so much the sickness, it's just actually a little bit more tired, because I think my body's working that much more harder on a shifting platform. So I noticed that I needed a little bit more sleep.
I think that's one of the things as well. So sometimes you can have seasickness without feeling sick and just have a bit of a woolly head and be feeling generally tired, and you can still carry on and work through that and not have to take medication for it. So yeah, definitely get different levels depending on the conditions and how prone to seasickness you are. Some people really suffer, particularly some people who go to sea for months and months of a year. They just put themselves through it and have their own way of coping so they can carry on and keep working.
I'm lucky in that I don't generally feel full-on seasickness ever on the big ships, but like Flick mentioned, I do get tired, because just moving around when you're in a moving platform is more work, and yeah, you do feel that. But I do suffer from seasickness on small craft. So our coastal research vessel we have here in Southampton, Callista, which is a wonderful 19-meter catamaran for coastal research, but it has a particular motion that's different to big ships in rough weather. And yes, I will suffer on Callista, and I think nearly everyone does. And this summer, I was doing some field work with colleagues from the Natural History Museum, and we were in the north coast of Iceland, and we were actually diving on very shallow hydrothermal vents, some of the shallowest in the world. The top of the chimneys in a field is at 15 meters deep. And so we chartered a very small, what's usually a vessel just for carrying a couple of divers out there to dive on this. And we set up our micro ROV down in the sort of cabin forward, but none of us could do more than 5 minutes down there, because you don't have a horizon. It's a very confined space and it's moving around a lot. And so we were on a sort of perpetual rotation to try and get the work done. So for me, small vessels. So I do sympathise with anyone who also feels it on the large vessels. And yeah, it can completely lay someone flat for a few days. I've had a PhD student in the past who 3 to 5 days at the start of the cruise. It's completely debilitating. You do then, as they say, find your sea legs. The problem is sometimes when you then have a period of calm weather and you recalibrate and reset, and then you get seasick again when it picks up again. So it can come back. And it can surprise you at any time, I think.
And seasickness can also result in a number of health complications. I mean, particularly if people are ill and are vomiting for long periods of time, it becomes very difficult for them to keep water down, for them to keep food down. And so, I mean, if the condition hasn't improved after a number of days, and neither has the weather, it starts to become a little bit of a concern for particularly chief scientists on board cruises. Because again, there are risks associated with dehydration, etc. So it's something that always has to be taken into consideration. Yeah,
in fact, that actually raises another odd medical condition that's surprisingly prevalent, particularly when we're talking about manned submersibles, and that's kidney stones. And this relates to the dehydration you just mentioned, because submersible pilots, the people who are in the vehicles, on a far more regular basis than scientists as part of their work, there are no facilities on board, of course, and you're possibly in that sphere for 8 to 12 hours. And so they don't like to drink a lot, so that they don't need to relieve themselves during their working day in the sub. And that makes them much more prone to kidney stones. And I've actually known 2 expeditions where we've had to medevac because of kidney stones, submersible crew. So it's an occupational hazard that you might not expect.
Yeah.
It's a very painful one.
Yeah. Although the money ROV pilot, I think, hopefully should cover the medical bills for that.
Yeah. Although it raises the issue, which I think also came up in discussion about what do we do on an expedition when we have that. So of course, preservation of human life is always paramount. So we will break off, and we will, if there's another vessel that we can medevac someone to that is heading to port immediately or has medical facilities on board, perhaps, great. If not, we will have to break off and head to the nearest medical assistance that we can get for that person. But of course, it is costing us £20,000 a day. So and we have a fixed amount of time for that expedition. So we're always, that's why we all have medicals before we're going to sea. I think someone else asked one of the things about why do we have to have dental certification? For much the same reasons. The last thing we want to do is to lose the time with all the costs involved, and that's years of planning, and that's our one slot to get work done. Toothache can be again utterly debilitating and horrible for people.
And I think that dental problems are one of the leading reasons why cruises have to be aborted, or why people have to be medevaced from ships, because of the associated complications, as well as again dehydration, lack of food, not being able to consume food, also causing a lot of problems, particularly on oil rigs and oil infrastructure. Okay, well, moving on from personnel, if you like, to equipment a little bit, which of course we touched on in week 5. And we had a question from Dan Kirk talking about what happens when we've lost equipment at sea, which, as you know, does occasionally happen. Do people ever attempt to find and recover lost ROVs? Would it not be useful to do so we can analyse what's gone wrong and possibly come across some salvageable parts? So I think some of us have been on cruises, or maybe I'm the only one who's been on cruises where we have lost bits of equipment. So I can keep the ball rolling with that one. We make every reasonable effort to recover the material, particularly because often a vehicle, a facility it's a sum of lots of components, and some of those components may be salvageable. So, for example, I was aboard when we had an accident with the ISIS ROV, but in that case, it was actually at the surface and largely salvageable, which is important to understand what had happened. But also, several of the camera systems, several of the bits of kit were still functional and rescuable, if you like. We took them off, we put them on another tow platform, adapted it, or rather our engineers did, thanks to their ingenuity, which we were able to use to carry out some of the work that we'd hoped to do. So we do make it reasonable, but I think if something is lost at great depth, then the effort that would be involved in locating it really is beyond the scope of what we could do to get that information if it may be useful. So I think, for example, the Nereus vehicle, which was lost earlier this year in a trench at 9,000 plus meters. Actually you have a problem there because you don't have any other bit of kit that can actually get down to do any sort of salvage. So you just have to piece together the data you have to try and figure out what happened in those circumstances.
Also, in the case of moorings, like in one of the cruises I went to, we had a mooring which is an array of instruments that are recording year long, and then you go once a year or every time to recover it. One of them got stuck and wouldn't go up to the surface, and what we tried was going around it with sort of like a rope around the mooring instrument to try to get that rope hooked to the mooring and then pull out the instrument or the whole instrument. In that case, it didn't work, but other times it's worked. And then you recover not only the instruments that, in the case of moorings, they are not as expensive as other robotic instruments, but also the data that they contain is very valuable. So it was a good effort trying to recover it when possible.
Yeah. Okay, one other question on life at sea, I think, before we will perhaps talk about some of the issues that have been in the course this week. We had a question about how much time on average does a scientist spend just relaxing compared with working when we're at sea?
What was that word?
Relaxing. So I think you can get some idea of the answer there. I'll start by prefacing that there is because we are working at sea and we're actually signed on the ship's articles as crew, we are therefore bound by the rules that govern mariners working at sea. And there are regulations about number of rest hours in a 24-hour period and over a 7-day period that we must have for safety reasons. So we obviously observe those with our watch patterns and so on. But that is kind of like the amount of time you'd normally spend asleep in order not to be utterly exhausted after a few days. So outside of that, how do you find it when you're at sea?
I think it depends a lot on what sort of cruise it is. Because the ones I have been to, it's like physical oceanography, you kind of try to use as much time on the ship as possible, which is 24 hours of work. It's very expensive and you try to make most of it. But we had shifts. So we had our scheduled timetables, and mine were like 8 hours long, but there's always work to do afterwards. You can always keep working and doing all this stuff. There's always something to do, but you also need some time to rest. So we had time for reading, for our own, for the bar. So I know some other cruises require much more work or dependable hours. It's depending on when you reach the site or the work you want to do. But,
Yeah, I was on a cruise earlier this year in July, and we trekked up to the North Atlantic, and the purpose of that cruise was primarily deep sea coring. But at that time of year in the North Atlantic, we have 24-hour daylight, so that provides quite a useful opportunity to do deck work on a 24-hour basis. In that instance, we were working 12-hour shifts. And as Christian said, sometimes those shifts ran a bit longer depending on where we were in the process of extracting cores. In those instances, you may well have maybe 2-3 hours after your shift to eat and gather yourself before you literally pass out from exhaustion. Coring is a particularly laborious work. Cores are particularly heavy. They're often coming up in quite rapid succession. You might be able to take 20 minutes to grab a bit of food midway through, but the shifts were pretty rigorous.
For the cruise that I was on earlier in the year, we had very standard shifts, which I think having a routine allows you to sort of get into a routine to begin with. But for me, at the beginning of the cruise, I was working on night shifts. So the hours that I had as relaxation hours were actually taken up with just adapting to the complete change in in my routine. I was not used to working at night, and it was not easy to adapt into that. But once you've got the routine established, and you know when you're going to do your laundry, when the meals are, and when you're going to sleep, then you can often grab a little half hour, an hour, just for relaxing and talking to the other people on the other shifts.
Yeah. And you always know at the beginning of the cruise and the end of the cruise there's going to be a chunk of time, whether it's while you're steaming back to port or when you've already got there and you've got some time before you catch your flight home or something, where you can really relax together and just enjoy yourselves. But while the cruise is in full swing, you want to make the most of that. If the weather's good, if everything's going well, all of the vehicles are operating properly, you really make the most of it and get as much out of it as you can. And most of us are also busy trying to work on samples as after they've come up, whether you're on shift or not. If it's your work and that's your only opportunity to have those, you really make the most of it. But we're also working on our regular work as well, that when we can, when we've got the communications to do that, and talking to schools and things as well. So there's a lot to do. We have full days, we make the most of them, and nights.
And I think it does vary with the work, the nature of the work involved. So remotely operated vehicle expeditions are quite different to human-occupied vehicle, man-submersible expeditions in the sort of daily cycle of activity. When we're working with an ROV, of course, we're remotely controlling it from the ship, and we work round the clock in shifts in the control van. And that requires a great deal of concentration. And the pattern that we've adopted on expeditions is 6 hours for that. But actually, I think within that 6 hours, it's hard to maintain, absolute peak concentration. There are several roles within the control center, and it's good to cycle people around those quite often so that people stay sharp like that. Some other operators, do shorter shifts, 4 hours, depending on the nature of the work. But that's going on round all the time. Then when the vehicle comes up, it's got all the samples and so on. You have to then process the samples while the vehicle is being turned around ready for the next dive and so on. The manned submersible human occupied vehicles are a little bit different in that whilst the vehicle is down, you're not if you're not on the dive, you're not involved in driving it or making decisions about what samples to take. That's the person who's on the dive. So actually in the daytime, it's a little bit quieter, and you're either able to catch up with processing the samples from the previous dive, or actually that is your rest period. Because when the sub comes up in the evening and it's got all the samples, then you have to process that rapidly and you do all the triage. And usually that's very long evenings in working through into the night to get all that done, particularly where what you have to do to the samples to preserve them or whatever is quite time critical. So you've got to do it straight away and in a very ordered fashion. So that means you are often working through into the small hours, and then you're catching up, and your sleep period then is during the dive the following day, unless you're one of the people diving. So the cycle is a little bit different depending on the technology you're using for that kind of work. But it's important to get into a routine, particularly if you've got a long expedition. This time 3 years ago, I was in the Indian Ocean, and it was a long trip. It was about 7 weeks. And it was very important to get into a daily cycle. So on that, yes, I know that I'd start at, I'd actually take over watch at 4 o'clock in the morning, and I'd be on watch till 4 o'clock in the afternoon with other people coming on at about midday to help our watch team. But then when knocking off at 4 o'clock from being on watch, I'd then have 1 hour for sort of a bit of exercise, bit of fresh air on deck before getting ready for dinner. And then after dinner, a chance to catch up on the other work and emails and things. So then you've got to be in bed by 8 o'clock and asleep by 8 o'clock in order to be up at 3:15 in order to get a shower and be ready to take the handover of the watch at least quarter of an hour before official watch start. So, but once you get in, you recognise that, and you get a cycle that works. That allows you to keep that up for a long time. So having that routine is really important. The one experience I've had where you don't kind of have a routine, but I've only done it kind of twice, is the chief scientist role, where you are, in a sense, you're on the go all the time, you're awake, in terms of decision making, which is a little bit more challenging. So from the limited experience I've had of that, what's helped is having very good watch leaders whose decisions you can delegate decisions to. So when you eventually do have to go to sleep, you know that you kind of have talked through what the current issues are and any decisions that are likely to have to be made while you are asleep, and they're not going to need to wake you up and phone you up unless it's something unexpected. You know what the options are and how it's likely to pan out. And then when you wake up, the first question you always have in your mind is, what are we doing? What's actually going on? What equipment is currently being deployed? And you need to always look out the window and figure out and go and talk to people. That is a bit more challenging because you are ultimately making the decisions and can be called on to make the decisions around the clock. So again, having a system but having a team is a way to cope with that, I think. Okay. So one other logisticsy related question, actually, but it was a little bit further down the list because I think it was a question asked in the step for this week, that is the Hangout. Simon Hodgson asked, interested in knowing where this discipline is going in the future, and as part of that, what fantasy vehicle or piece of equipment would we like? So we'd like to start us off on that.
I think for me, I'm land-based with my research, really, although I'm looking at sea level because I'm looking at the growth of ice sheets. So at the moment, I'm trying to reconstruct an ice sheet that was over Europe about 140,000 years ago. Now, the data that we've got is very, very sparse. So what I would like is some kind of magic sonic screwdriver that I could point at a rock, and it would tell me if it had been under ice, if it had been under ice, how long it had been under ice, and how thick that ice was. If I could have that bit of kit, I think I would be well on my way.
In my opinion, is similar way. We could have like a magic instrument to work out things that we cannot at the moment. I would be happy having sort of like a satellite work that they can have a very precise and high resolution data, but only on the surface of the oceans. It would be great having something like that for the full depth of the oceans, where you can look at the properties like temperature, salinity, or other stuff, just with a glimpse of something flowing through rather than individual points or profiles.
I would love a portable radiocarbon analyzer. One of the things that I work on particularly is submarine landslides, as I mentioned. And particularly important is being able to date those submarine landslides. And one of the ways in which we do that is we use carbonate material, which sits either below or above the landslide, to estimate its age. One of the problems with that is that preparation of radiocarbon samples is generally a fairly time-consuming process, as I'm sure maybe some of the people here are familiar enough with. So yeah, a portable version of that would be an indispensable tool.
And I don't really have a fantasy piece of equipment. What would really work well is if we didn't have to wait as long to be able to get to sea and to be able to use the vehicles. That would tick my box. Are you happy with that?
For me, it's something I think we are working towards, but it's in an ideal scenario, I would like all the data we get from our underwater vehicles to be integrated in real time into a sort of augmented display. So we're getting there at the moment. Now we go out and we do a dive where we map in high resolution with the vehicle, and that's then the base map we use for then navigating the other dives, and much better than when I started 20 years ago, where you didn't know where the heck you were at the bottom of the ocean most of the time, and you were kind of navigating by landmarks and hoping for the best. Now we can see where we are on these maps with a reasonable, much better degree of accuracy, although it does get more difficult the deeper you go. But I would like something that brings together all of the data into some sort of, when we're looking on the video, we can see other data that are available, and the whole thing is put together to enable us to really work very effectively in the limited time, ultimately, that we get in this environment. So who knows? I think as computing power improves and so on, we could well see ourselves heading in that direction. I hope so.
Talking about that, there's a lot of efforts now trying to do a proper data management. We've got so much data around, and so hard to get hold of it or decide what to use or not. So looking at how to properly save it, and obviously making it available for other people eventually in many years, and not to lose that data, is an actual present effort right now.
It's a challenge for all of our disciplines. Yeah.
Okay, well, let's move now from talking about the sort of logistics and how we explore the oceans now to some of the issues we've been looking at this week in terms of our impacts on the oceans and the future of the oceans. And we've had quite a few questions about resources, deep sea resources, and ocean floor mining, and its how that's managed. So we'll take a few of those, I think. First of all, we have a question. Let me just look at my list. I'm on the wrong page. We had a question about why do black smokers shut down at a particular vent field? Why don't they last forever? What is it that makes them ephemeral at the sort of scale of a set of vents that we call a vent field? So I think we can easily start with that one.
Okay, for it.
Okay, I'll take that one to get us going. Venting doesn't last forever at any one location for several possible reasons. You can have a situation where a vent field is actually covered over by a fresh lava flow. And so where you had the venting, now there's a big pile of pillow basalts that have been deposited on it. So obviously the venting can't come out at exactly the same location. Now it may carry on venting and find a new route out somewhere nearby. And that's something that we do know happens. We can have earthquake activity kind of fracturing or interrupting the plumbing of those particular set of vents, because remember the vents are fed by conduits down in the crust. We can get movements of the crust that could shut it off in that particular area, and so on. We, of course, are seeing at the vents, we're seeing deposition of the minerals, forming the chimneys and so on. Well, that deposition is also taking place in the stockwork underneath the vent field as well, and could actually sort of clog that up, and fluids may find their way elsewhere. And then I think also, actually, fundamentally, the circulation of fluid in the porous crust is a sort of slightly stochastic process, and it does shift about as well. So for those reasons, the focus of flow may move. So there are lots of reasons. It varies, of course, depending on, if you think about all those different activities. So we've got volcanic and we've got tectonic earthquake type activity. So if we're on a part of mid-ocean ridge that's spread, where the plates are spreading apart particularly rapidly, there will be proportionately more volcanic activity, more earthquake activity events won't last as long because those sorts of disruptions will be more frequent, more common. And that's the case with the slower spreading mid-ocean ridges, where we see venting lasting for thousands of years instead of decades, based on dating of the actual mineral deposits to figure that out. We haven't been watching them for thousands of years, of course. So that's actually part of the important pattern. That not all vents are the same the world over. And the marine life, of course, varies around the world and is adapted to different levels of natural disturbance for that reason. So that's an important thing for us to understand. Another question that we had about the mineral resources was about the quality of them. Are the metals that are recoverable from the ocean floor of better quality than those that are mined on land as a result of the processes that they're undergoing? So anyone want to take that one?
You can do it.
Okay, well, having spoken to Professor Roberts, who gave the video this week about metals, in particular forming vents and so on, in some cases the answer is yes. They are richer in terms of their yield of the ores of metal. But not in all cases, but in some cases, the copper content of some of the deposits at the vents on the ocean floor is 10 times the copper content by percent of what's mined on land. So yes, potentially high yield. However, they are not as big. It's not as massive a sort of deposit. So the actual total amount of copper, yes, it's high yield, but it's much smaller volume. So, you know, it sort of swings and roundabouts a little bit. And then there are these other sort of trade-offs involved in whether something might be economically viable or not, in that they're quite small deposits, but you don't have to get down through a lot of overburden, a lot of other rock and so on to get to that deposit and mine it. If you can scoop it up from the ocean floor with some fairly straightforward technology, you can get it all without having to do that. Now, not all of them are that high grade, and again, it depends on the nature of the geological setting and the type of ridge and so on where the vents are formed. So some of them, yes, much richer, some of them less so. And I think this will obviously guide mining interest, and it will feed into the economics. And just as an aside on the economics, I mean, it's a very complicated system as well, because if you suddenly mine a lot of copper from a new resource and put it on the market, you'll depress the price. So there's a human aspect to it as well, in terms of how this works. So yeah, it certainly is very complicated. But yeah, certainly for the vents, for the copper, yeah, we can see enrichment compared with deposits on land. I'm not entirely sure about manganese nodules and cobalt crusts, which are the two others, not being a geologist, I'm afraid, how they compare to sources on land. Rare earth elements, which of course are one of the interests in the manganese nodules, yes, there it's not, I don't know about enrichment, but it's about security of supply and who controls the majority of the world's terrestrial sources of those resources. So that's a big issue. And now, of course, rare earth elements in the actual mud of the abyssal plains. And that is quite rich, apparently, according to research. How easy it is to get out, I don't know. That's in the realms of geochemistry. So I hope that helps to answer that sort of question. And then we've had a lot of questions, a lot of interest about the sort of management aspect of ocean resources, which I think are, are very broad, something we can discuss. And particularly people are concerned about enforcement of conventions, and what if all countries don't sign up to them, and that kind of thing. So I think we can take that. I mean, David Stanning, for example, has asked how will these conventions be enforced, and I think that's an open question. I don't know if anyone has a particular view on that.
Ocean policy, Guy, if I'm honest with you. It seems to be that the ISA doesn't seem to have a massive amount of, I mean, I was from reading information on your blog, the ISA is fairly limited in the amount of enforcement capability that it has. So I mean, if you wanted to expand more on the ISA in particular.
If we start to think about how we've managed fishing thus far, it's not exactly a good case study. So if we can't manage our fish stocks, how on earth are we going to manage the minerals? I'm very cynical about it, sadly.
Yeah, I'm with you on that. But I think there's already a kind of precedent really where countries don't have to sign up for responsible management. So I don't think we can just may wave a magic wand and make them suddenly want to be responsible.
It's going to be a lot of hard work,
Yeah.
an awful lot of hard work. It's going to be miserable. I think.
Getting so many different countries, it's getting an
Yeah.
interesting point and agreeing on how
Well,
to use the
yeah, and it's
resources.
such a conflict of interest.
Yes, or share resources.
Well, I mean, and
It's
also, I
really
mean, larger countries also have very, very disparate demands on resources. I mean, so limiting, sort of applying universal limits to resources is always going to be a problem, and particularly like countries like, you know, developing countries and up-and-coming countries like China and India, they have huge demand.
And how dare we say that they can't
Yeah,
do what we've already
exactly.
done?
Yeah, I mean, we've been mining resources out of the earth for centuries. So, I mean, to now say is maybe a little bit hypocritical. But
It's more than that.
Yeah.
And there was a question in the forum as well about how can, you know, countries that don't have a coastline, any sort of offshore technology, how can they benefit from these resources? And the ISA is set up to try and address that. And their solution is, whenever anyone goes in with a license, then they set aside part of it, half of it usually, which can then be developed by the ISA, providing the technical support, with developing countries that don't have access or don't have technical capability. So that's the thinking there. That we haven't reached that phase yet to see that actually working. If there are no takers for that, I think the ISA retains the right to develop that half with its own enterprise commercial arm, which to me is a bit of an issue, because then it's in the ISA's interest to award licenses. And there's now talk about, okay, you're right, fisheries is a good point. We currently manage our impacts in the oceans in a very disjointed fashion. We have instruments and bodies that look at fisheries, that look at ocean dumping, that look at different problems. And of course, the ocean is a connected ecosystem. We need to consider it in a more joined up fashion. And so there's talk about there being some sort of body having overarching responsibility for looking after you know, the environmental stewardship of the oceans. And in a sense, the ISA would, on the face of it, appear to be a logical choice. But I think it needs some serious reform of the details of its current governance for it to be able to do that in a way that everyone can have trust in. And I think that's the issue, is that we can all see that there aren't inbuilt potential conflicts of interest, whether they are realised or not. They shouldn't be there. If we're going to try and do this properly. And I think that's a huge challenge for the people that get involved in defining policy. It will be interesting to see that there will be a report, I think, by the end of 2015 about how the global governance of ocean stewardship should go forward, should the ISA take on more of a role for biodiversity in the oceans and so on. It'll be interesting to see what comes out of that, and then how it has to develop beyond that. So we shall see. On that, I think. Time will tell, but obviously we you know, at the same time we need to be doing research and providing the input on what our impact's going to be to help with that. So that's something we've got to catch up on. We'll keep pressing ahead all the time, of course. We had a question about metallic nodules as well. How do they form extremely slowly on the seafloor? And if they do, why don't they get buried in sediment? And that's, again, outside my area of expertise.
I answered a question about this on the MOOC forum yesterday or the day before. As I understand it, in instances where metallic nodules form in relatively long time periods, so they form in very, very slow increments. The reason in a lot of cases that they're still exposed on the seabed is, one, bottom currents, very gentle bottom currents, are able to slowly remove the fine sediment from accumulating on the surface. The nodules, obviously being much denser and heavier, stay where they are and aren't influenced by the currents themselves. But obviously the fine detrital material that tends to fall out of the ocean water column is sort of gently swept away by the currents and prevents it from settling. Another proposed mechanism was that sediment living organisms also, through their feeding activities, eject material off of the top of the metallic nodules, and again keep them relatively close to the surface. But it is worth noting that there are instances where a lot of metallic nodules are in fact buried under quite deep superficial sediment. Metallic nodules can also form relatively quickly in comparison to the million years that some form. It depends largely on the enrichment of the water, so the supply of the amount of manganese and other metallic dissolved elements in the water, and they can often form again quite rapidly and then lay in large numbers on the surface of the sediment.
Okay. We're nearly out of time, I think. So I'd like to finish just by going around the table and asking each of our participants here, what is the key impact that's the primary concern you have for the future of the oceans? So what's the one, if you had to pick one thing, what is the one thing that is of most concern to you in terms of the impacts we're having on the oceans, and what can we do about it in the future? So it's a very big question to just throw at you, but
yes, to me, I think that our research efforts are showing what's happening, all the problems we have. My main concern is how to reach those policymakers or society to be consequent and try to diminish as much as possible those impacts.
I think one of my most significant concerns is, I'm sure we've covered it in the course, is ocean acidification. Ocean acidification as a process threatens an enormous amount of ocean life, particularly calcareous organisms on which a lot of trophic structures are invariably based. And I think by endangering those basic levels of the food web, it could play havoc with larger marine organisms that we see, particularly fisheries, obviously species like krill, on which much larger organisms feed. I think that's a real concern.
I think for me, it's we're relatively agreed on climate change, and the fact that we're now seeing a warming world, and that will result in more ice melt, and that will result in sea level change. And how much of that sea level change is going to affect whole populations that have not contributed to the warming world? I think for me, that's a huge impact.
For me, it's mining, particularly at hydrothermal vents, because of what I work on, and because I don't think we're at the stage where we can fully inform what those potential impacts are going to be. And it's going to be, to some extent, one big experiment to see what actually happens. And by the time we work that out, it could be too late to fix it. So.
And I think for me, it's the big challenge is ocean awareness in our growing global population. So over the past 20 years of working in ocean research, there have been a lot of ongoing excellent initiatives trying to raise awareness of what's happening in the oceans and the effects our everyday lives have in the oceans. So we have things like Mission Blue, and now we have the Global Ocean Commission that's trying to feed this through to policymakers and so on. And I think that's excellent, and obviously we have to do that. But we seem to be putting all that effort in and largely holding our ground through that effort. We're kind of at a bit of a stalemate in terms of the big changes. And what concerns me is by 2100, looking at the most recent projections of population on this planet could hit 11 billion. And a lot of that growth is projected to be in Africa as a continent, and resource use as well. I mean, over the past 40 years, the amount of calories on average that people consume through meat has doubled, and that's a whole other debate about meat and so on, but that's an indicator of development, and there's a lot of things I think that correlate with that, such as our generation of waste and so on. And you can see that not only is our population growing, but our pattern of resource use across that population is changing and intensifying as part of development. And a lot of our ocean awareness initiatives at the moment are in the developed world, and I think we need to be looking ahead and planning for 2100. And we need to be putting huge efforts into education in the developing world over that coming century, because otherwise everything we do in the developing world will only be a fraction of the global impact that we're having on the oceans by then. So we need to plan ahead. We need to keep our position where we are now, but we also need to look ahead and beyond for the future. And of course, you know, that's a huge challenge, and there's a whole bunch of other issues tied up in that. So I think, you know, we have a a difficult century in front of us for the future of the oceans. So that's a, I hope neither a particularly negative nor positive note. It is a challenge. And I think that all of you who've taken part in the MOOC hopefully, you know, obviously came with an interest in the oceans. And the more we can do to further that, then clearly that is the only way we can hope to address this challenge. And so thank you all for your participation. I hope you have found it interesting. I hope you found out new things about the oceans that you didn't know before. And it may in some cases have changed the way you look at the oceans. And I hope in some ways it makes us all, putting this course together has made me think about the things I do in my everyday life that have impacts that I wasn't necessarily really thinking about before. So I hope that's something we can all take away from the experience. And I'd like to thank all of our mentors and fellow educators for putting in the effort. And I know from the feedback in the forums that I know our learners have really appreciated that interaction and direct input that you've had. It's not just a sort of one-way online thing like that. So I know that's very valuable. And I certainly feel as an educator that I always benefit from those interactions myself. You know, I learn a lot of different perspectives about ocean issues from doing this sort of thing. So hope you have enjoyed the course, enjoy whatever remains of the final week. Of course, the materials will be available for you to access, I think, for at least a year through FutureLearn. And we will be carrying on with our research in our individual areas, of course, and we'll be doing everything we can to tell people about what we're doing. So please do come to our website here, University of Southampton and so on, and see about the opportunities to follow along with what we're doing and get involved where you can. So thank you all very much for your participation.